In a nutshell, how buffer overflow attacks work is they exploit flaws in code, bad coding, specifically bad buffer handling and bad input handling and bad networking can allow certain types of code to fill up a buffer, fill up a space in memory, fill up a part of a computer that can't handle that much data, sending way too much data to a specific point on the computer or in a process that can't handle it. What happens is we fill up with the buffer overflow, the buffer, the allocated buffer of memory, and then the stuff that happens after that. If I send a bunch of data and then some extra stuff after that, it's the unpredictability of what happens to the data after that input is supposed to be terminated. And I'll show you a specific example of how that works in a moment. Ultimately, it comes down to good code will check to make sure that it never accepts too much data, never tries to put too much data in a buffer. Therefore, a buffer overflow would never occur and is not vulnerable to either an attack or a failure. Here's a really basic version of buffer overflow as code. And all it's showing you is that I've got here a couple of different variables, but they don't have any coordination between the size of them, between the actual size of data that's stored in these variables, in these buffers, if you will. And there's no checking to make sure, oh, this string is too long or this buffer is too small. Because there's no checking of the buffer size, if I stick too much data in one, it can actually make the other one blow up. So that's a real basic example. I want to actually show a little bit more of an applied example. In more of a current applied example, let's say you go to a web page or an application that asks you to log in, and the input title on it says username must be between 6 and 24 characters. Okay, so I type 5 characters or 4 characters. I'm a really good hacker, and it errors out. It says, oh, nope, got to have at least 6 characters, between 6 and 24. What I'll try to do to manipulate this code is I'll actually type in 24 characters and then maybe some extra stuff like a command or like some kind of code or something to find out whether this software, this application is actually processing every bit of data I send. So if I put in all of this data, Mike Danseglio is a cool dude, run DLL32, blah, 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 from the second sub-bullet there, either that code after the 24th character is going to be passed to the shell for execution or the application is going to filter it. If the application is going to filter it, that's good. That's good coding. The person who wrote the software says, oh, there's more than 24 characters here. So I will stop that, send an error back to the user and say, oh, can't type more than 24 characters. The overflow, the buffer overflow flaw, is when the application fails to check for the length of it and simply puts all of that data on the stack. The application might read the first 24 characters and then the 25th and subsequent characters are still floating around there somewhere. Well, if there's another error, either a subsequent error in the code or compiler error or some kind of shell exploit or operating system exploit, great. Now that code starting at character 25 actually gets executed, whether it's by whoever's handling the network input or in this case, the application input, or by something else. Doesn't matter. For purposes of this, it's about whether that stuff gets executed or whether it just gets truncated or whether I get an error message back. And this might seem pretty simple. You would think that any application that wants to check for username or that accepts username of an arbitrary length is going to check to make sure it's the right number of characters, and it's also going to check to make sure that it never passes any data to anything else or puts any data on the stack or in its memory space that might be code or might be some nefarious stuff. But you'd be wrong.